The notes in this lesson will cover section 2.3 and chapter 4 in your textbook. Make sure you pause the video at any time if you need to take more time to write down the information. So before you take the notes, make sure you have your blue notes packet available so you can copy down all of the slides. So an atom is the smallest particle of matter that retains the element's properties. And the three subatomic particles within an atom are protons, neutrons, and electrons. So next we'll complete this table regarding protons, neutrons, and electrons. Starting with protons, the symbol for a proton is a P with a plus sign. The relative charge for a proton is positive. The relative mass is 1 AMU. So AMU represents atomic mass unit. And protons are located inside the nucleus. Moving on to a neutron. The symbol for a neutron is an N with a little 0. Above is a superscript. Neutrons are neutral, which means they do not have a charge. The relative mass is also 1 AMU. And neutrons are also located within the nucleus. So protons and neutrons are the two particles that are located inside the nucleus of an atom. Electron, the symbol is an E with a little negative symbol. Electrons are negative. They do have a slight mass, but for our purposes, we do not use the mass of an electron to calculate mass number, so we can just say electrons essentially have a mass of 0. And electrons are located outside the nucleus in the electron cloud. So again, if you need more time to write down this information, be sure to pause before you move on. The nucleus is the small, dense center of an atom, which contains your protons and neutrons. So if we draw a picture of a carbon-12 atom, and if we label our protons, neutrons, electrons, we'll see how well I can draw this. So the two particles that are inside the nucleus are protons and neutrons. So carbon-12, this is the symbol for carbon-12. So we'll get more practice with this later, but this top number is your mass number. This is hard to write with this, so I apologize for my sloppy handwriting. So mass number. You'll get more practice with this later. This bottom number is the atomic number. And the atomic number also represents the number of protons in the nucleus. Whoops, my writing is getting a little shaky. Okay, that's your atomic number at the bottom. So because the atomic number of carbon is 6, that means it's the 6th element on the periodic table. So in my nucleus, I'm going to put 1, 2, 3, 4, 5, 6 electrons, and then 6 protons. And then over here, I'm going to put that pink equals my proton. Okay, then I'm going to switch colors. So we'll do blue. Blue is going to be my neutrons. So to find neutrons, before I start adding neutrons, protons and neutrons will add up to equal this mass number. So since we have 6 protons, we are also going to have 6 neutrons in this case. So here's 1 neutron, 2 neutrons, 3 neutrons, 4 neutrons, 5, and 6. So that equals my neutrons. Oops, my N didn't transfer very good. Okay, so now I'm going to switch colors again. We'll do bright green. And bright green is going to represent my electrons. So those are my electrons. And electrons are located outside of the nucleus. So for now, with atoms, atoms are neutral, which means that the positive charges have to equal the negative charges. So if I have 6 positive charges in the nucleus, I am going to need 6 negative charges out here on the electron cloud. So here are my 6 electrons outside the neutron cloud, and here is my nucleus with my protons and neutrons and electrons. Oops, let's see if I can advance here. Oops, and now I got to erase. All right, sorry. I apologize for my time erasing. Okay, last few terms that you'll write down today, and then we'll do more practice another day, is atomic number, identifies the element on the periodic table. This number represents the number of protons. Mass number, which is not on the periodic table. The number listed on the periodic table is called the average atomic mass, not mass number. So you have to be super careful. Mass number is not on the periodic table, and it describes one specific isotope. Mass number is found by taking the number of protons and adding them to the number of neutrons. And last term for today is isotopes. So isotopes are elements with the same number of protons, but different mass numbers because they have a different number of neutrons in the nucleus. So for the rest of today and tomorrow, we'll be practicing with different isotopes. So with isotopes, we'll identify the number of protons, neutrons, electrons. You'll calculate the mass number. So we'll practice mass number and isotopes and identifying these things over the next day. And then the next day, we'll move on to average atomic mass. So again, if you need any information from this, make sure you go back and review the slides. Otherwise, we'll do more practice with isotopes in a different video.